In this module, we are discussing SQL injection attacks. How the attackers take advantage of vulnerabilities in the web applications, and several steps to mitigate. Let us go through some examples of attacks. Earlier, the telecom giant in Canada lost tens of thousands usernames and passwords, and valid credit card numbers were stolen from a third-party supplier's systems. One high-profile SQL injection attack was aimed at Card System Solutions, a company that processed payment data for credit card companies. The hacker used a SQL injection attack to install a program that transferred credit card data from a database every 4 days to a remote computer for about 6 months or so, until the company noticed. By that time, attacker stole millions of card data. You will learn more about various types of attack style. Life cycle of an attacker in another module. As a result, banks reported millions of dollars in fraudulent purchases using counterfeit cards. The hacker is believed to have had access to 40 million credit card numbers, and data was stored in an unencrypted file accessible from outside the company's network. In another case, the attacker targeted the Sony PlayStation network. This attack exposed records. Over 70 million Sony PlayStation users, including usernames, passwords, credit card information, security answers, and addresses. This attack serves as another lesson in how to better protect valuable information. This attack was successful because passwords were not stored in a hashed format. Just before we understand what is SQL injection, I just want to inform you all that the number of techniques we show in this module may work in the real websites. Just to keep ourselves out of the troubles, try these on the test websites, which are your own. Testing on live website or production websites may create trouble. With that, let us understand what is SQL injection. SQL injection is a common attack vector that uses malicious SQL code for back-end database manipulation to access information that was not intended to be displayed. SQL stands for Structured Query Language, is a standard language designed for managing database. SQL is a standard programming language specifically designed for storing, retrieving, managing, or manipulating the data inside a relational database management system. Many web applications do not validate the information in the forms, allowing an attacker to inject malicious SQL commands or queries that are executed by the database. The attacker then uses automated tools to collect information from any tables and columns in the database. The next step by the attacker is to injecting more code to compromise the database server, thereby potentially causing the database server to download other programs from the internet that give a hacker wider control to attack further and retrieve data. SQL injection attacks are very targeted and are not likely to generate wide attention when they are attacking. When managing a website, it's important to stay on top of the most critical security risks and vulnerabilities. The OWASP publishes top 10 vulnerabilities around the world. It is a great starting point to bring awareness to the biggest threats to websites. OWASP stands for Open Web Applications Security Project. It is an online community that produces articles, methodologies, documentation, tools, and technologies in the field of web application security. According to OWASP, SQL injection is in the top 10 attacks for more than a decade, and applications around the world are vulnerable to these kind of injection attacks. Let us understand how the SQL injection attack happens with an example. Consider an example of e-commerce website which is running in a safe environment with HTTPS secure protocol. In this example, consider we have purchased a lot of goods from the website. Over a period of time, we can go back and check the order of the history. Here, customer is logged in and wants to check the history of orders using the order history page. Customer enters month as 07. Search the order for the month July. check the orders for that month. Once the customer provide the input data, which is here the month, and search the order history, the form order history process the SQL query. It selects the display information from the order history table. It selects title, description, quantity and order day from the table order history. For the user logged in and for the month of July, the user ID is picked from the session created by the web application as session.getUserID and month as request.getParameter for the user provided month. Here in this case user ID returns 1, 2, 3, 4 and user provided the month 07. Sample information for the customer is shown. Unfortunately, the attacker can take advantage of the vulnerability in the implementation of the website. Let us go through how an attacker exploits the vulnerabilities. Instead of just entering the month, attacker can enter 0 or 1 equals 1. The construction of the query from the form is changed in the web clause now. Now the order history month is 0, and there is no information for the month 0, as there no month is 0. This part of the SQL query returns nothing. However, the next part of the query condition, or 1 equals 1, is true. We are always known that the Boolean logic, 1 equals 1 always true. When this SQL query is executed at the database, what data is returned is the complete information of the order history table. And more importantly, the information returned to form is not just for the particular logged-in customer, but all the customer data is retrieved. If this kind of data is available to competitor, it will help to know what kind of business the company is doing. Once the attacker gets to know that the website is vulnerable to SQL injection attack, they can perform enhanced attacks to get more information. Change the web clause further. When the web clause changed to 0 or 1 equals 0, union, select name, card number, expiry month, expiry year from a credit card. Now look at the SQL query. Instead of 1 equals 1, now the input changed to 1 equals 0. Now the where clause is 0, with no result in the table. Similarly, 1 equals 0 also returns false. Look at the first query. Select title, description, quantity, order day from order history, where user ID equals 1, 2, 3, 4, and month equals 0 or 1 equals 0. The first query returned nothing. This is very much suitable for the attacker, as the second query holds the information. Now the attacker with the second query try to get the information from the new table, in this case credit card table. The information from the credit card table is merged in the result set of order history. It is possible as an attacker to exactly match the data type of credit card table fields with order history table. When this query executed, the credit card information are displayed for all the stored credit cards. The name, credit card number as description, expiry month as quantity, and expiry year as order days are displayed. Apart from the details required for competitive analysis of the customer earlier, now attacker has credit card details of all the customers. If the web application is designed to hold credit card information, user-sensitive information, one has to take utmost precautions and mitigation to avoid SQL injection attack, which result in data theft. SQL injection can lead to very severe attacks. Apart from the data theft, attacker can give 0, drop table credit cards. This deletes the credit card table. Then the website cannot do any transaction, which leads to dangerous DOS attack. Denial of service attack. Attacker can insert the admin user table with admin privileges user with known user ID and password to access the database anytime. When managing a website, It's important to stay on top of the most critical security risks and vulnerabilities. In the upcoming sections of this module, we will learn more. How to mitigate the SQL injection attacks.